Hello, water managers and SWMS users. I'm Russell Errett. I'm with the Water Management Systems Division out of the Hydrologic Engineering Center, and I am covering SWMS real-time modeling. This is the fourth part of a multi-part video series to cover this presentation, so if you want to see the first three parts, check them out in the playlist. We are covering the basic concepts for developing a cavity watershed for real-time modeling within SWMS. We went through a quick crash course overview of how to develop a cavity watershed for real-time modeling. And then we've also gone through real-time modeling for creating forecasts, time windows. We've looked at data set summary, editing and running models, and then some evaluating the results. And so now we're kind of at the point where we're going to talk about saving models and saving results. And then we're going to talk about a little bit more advanced features that are within the cavity and talk about some methodologies as well. So let's talk about saving and posting results. So the cavity watershed folder structure, we'll talk about this first before we talk about the saving part. The cavity works only with those three files we talked about. So there's the watershed, there's a forecast folder, and there's a database folder, right? So the three folders we're talking about, I've referenced some terms of what base is and what the setup tab is and what the watershed is. So the watershed folder underneath where your SWMS watersheds are located, this watershed folder is where all of your base watersheds, the watersheds you've created from scratch, are stored. When I say base, you can make that almost synonymous with the setup tab. The setup tab and base are the same things. So whenever I'm talking about base, that's the setup tab. The setup tab and the base are where the watersheds are stored. That is the watershed folder. So if you really want to think about it, the watershed folder and your watershed, your directory that you've defined for where your watersheds reside, that watershed folder is equivalent to base. It's also equivalent to that setup tab that we've been working with. There's a forecast folder. The forecast folder, when I say that they're making copies of the forecast run and making copies of the models themselves, the model alternatives that they need, that forecast folder is where those copies are being created. So they're copying it from the watershed folder. It's a subset of that base watershed, and it's being copied to the forecast folder itself, right? And so the database folder is kind of a supplement folder. This is where you can put a lot of your extra stuff. Maybe there are DSS files you need to extract from locally. So maybe there's some statistics that you like to run, like what's the average pool elevation for this time of year, or average outflow, average flow for this gauge. Any of those things you want to put in there. Maybe there's some discharge ratings you'd like to have available locally. Put those into a DSS file. You can have additional gridded sets. Sometimes get USGS just when you work within DSS view. You want to download USGS data through the DSS view locally. You might even have a script that does that. You can store those in a database folder. So it's a great place to overflow things. It's also a good place to put like water control manuals. So if you have like a water control manual for a project that's with that watershed, you want to be able to get quick access to it, go ahead and dump it in there. It's a good place to put it. Maybe there's some images, some SOPs. Anything you would like to put into that database folder, it's a good overflow for catch-all things that are associated to these watersheds. So let's look at these watershed directories, and I really want to talk about the forecast and watershed folder specifically. So as we described earlier, when you're defining your watershed locations, this one's CWC watersheds, and we have our three folders here. So let's look at the watershed folder itself and what that looks like when you're going into it. So inside of there could be several watersheds. So this is an example at St. Louis. There are 1, 2, 3, 4, 5, 6, 7, 8 watersheds in here. So each of these folders have their own model directories in there for that watershed. And so underneath one of those watersheds, so for example, the Mississippi, here are all the folders that are in there. And these are associated to model components. So here's HMS. If somebody asked you for the HMS model for the Mississippi River, this is the folder. I can rip that out and hand it to someone and say, here's the HMS model for the Mississippi. If somebody wanted the RAS model, here's the RAS model. This RAS folder contains all the files that are RAS for the Mississippi. I can hand that to someone else. Same thing with RSS, that would be your ResSim folder. And then there will be a METView folder in here. And so then there's a lot of other folders in here, and then there's also a lot of other components that are in here, like the stream alignment and projection. So a lot of things are in this folder. This is your base watershed or your setup tab. This is what we're referring to when we talk about base. So let's dig a little farther. If we go into the RAS folder, like I said, These are all the RAS files. So if you're familiar with RAS, here's your project, here's your plan file, here's your geometry file, here's your boundary condition file, here's your all your other unsteady flow files. Everything is in here for what RAS is needing. So there's also some other folders here, like this data folder. This is probably where my terrain data is sitting. So I have a folder inside the data. That's where my terrain file sits. This is obviously an output for a gridded set that we're creating for a depth grid. So that's where all that stuff resides in that base watershed. So there's a lot of files. Let's look at this same folder structure if we created a forecast for this watershed. So if we go and look at forecast, you can see all of the forecast folders. There's a folder for each forecast that's created. So these are like the default times. Inside of any one of these, there could be multiple watersheds. So for example, in 2022, on the 4th of December, all of these models were keyed off at the same time. So all of these have the same forecast time. They're all sitting in the same name folder. So you can create the same name of the forecast for different watersheds. And if I look into the Mississippi, what you'll notice is there's a subset of all those folders. So for this day, we didn't run RAS, so there's not a RAS folder in here. There's only METView, HMS, and ResSim. That is all that was run for today for that Mississippi, or for this day for the Mississippi. So it's a very select subset based upon the forecast run that's being done for that forecast. So this is a good reference to understand like the copies that are being brought over from the base watershed to the forecast folder. So let's think about that in the sense of how are we going to save models back and forth. So save to base, that's when we want to copy something from our forecast modeling tab back to our base watershed. So let's say we made some changes to a ResSim model and we adjusted the guide curve or some zones, or maybe we made some adjustments to the max release rules. Maybe there's some rating curve updates we may have done to some of the junctions. There's some HMS zonal parameters. Maybe we've adjusted those and calibrated the HMS model, and I want that to be available to me for the next forecast run I create. RAS, maybe you made some adjustments to your flow roughness factors that might be in your model, and you want those available for the next time you create your next forecast. You can save those to base. Generally, that's a lot of time this is done when you're developing the model. I recommend talking to your local office and finding out whether saving to base is appropriate, because there are some offices that have a policy that do not use save to base because they like to retain that base directory. So definitely talk to your office on how that's done. But saving to base is a way of having those changes available for the next time you create a new forecast. A replace from base will be taking it from your setup tab or your base watershed, and you may have, say, I made a mistake and I've gone too far in my zonal parameters for HMS. Maybe I've modified some ResSim rules and I've gone too far and I don't know where I'm at anymore. Maybe you've made some changes to RAS and you're like, oh, this is not right. And you want to go back to where you were at originally. Replace from base will copy it from your base watershed and overwrite what's in your forecast directory and you're back to where you were starting from. So don't be scared to break these models. Really dig into there, try to break a model. Don't worry about it. It's a copy of your base watershed. You can always either just not save it, or you can replace from base and bring it in and you'll get back to where you started from. So definitely try to, when you're learning how to run swims, don't be scared to break it. That's the best rule of advice that I've gotten from when I started. Just don't be scared to break it because you can always go back to the start. And even if you break your watershed, even if it's in the setup tab, you'll have a zip up copy. Somebody will have a backup. So definitely just make sure you back up your watersheds frequently. You can always just go back to the last time you zipped up your files. So the way you save to base, let's talk about where you save to base from. So if you were in the forecast, the modeling tab, and you're on the forecast run alternative highlighted, and you right click, there's a save to base option if you right click. Or in the Actions tab, there is a Save to Base. Both of them will pull up this menu, and it'll give you all of these checkboxes on which ones you want to save back to base. And by default, METView is grayed out. You can't save METView back to base, and I believe FIA is now grayed out as well. So you can save these models back to base if you want to. We're slowly starting to gray out some of these because I think we don't want a lot of people saving back to base for different reasons, but they're still available, and just definitely check with your district. One of the more powerful ones is replace from base. Like the replace from base is definitely something you can always get to. So the same way, right click on the forecast run alternative or go to the replace from base in the Actions tab. get you to the same menu, and then all these are available. You can replace any model from base. It's not just NetView's not grayed out. Any one of them can be replaced from base. So definitely do that if you feel like you've made some edits that you can't go back from. So posting results. So you can create a post list within the CABI. This is the same way as an extract list works. So you can post the results from the forecast.dss file to your database. And this can be used for creating a GIS dashboard, or maybe you're trying to create a chef file that's sent out to the National Weather Service or another core district office. This is the way you can create those exchanges if you're posting it back to your database. You can also, if you need to extract those, if you have another model that's dependent upon that SWMS watershed, you post it to the database, you can create an extract list to pull that data down so it's available for the downstream SWMS model. Also, there's going to be some requirements for you to post specific data sets up to the national database for the dashboard that the MMC tracks. So those are going to start to be required here in the near future. So posting results is a very powerful way of doing things, and it's going to be required here for certain data sets anyway. You can also, when you look at the SWMS implementation presentation, if you post them to a remote DSS file, you could also put a timestamp to it, and you can start to do an evaluation as like post-processing. So there's version time series, or you're saving all the traces for later on and doing some accuracy on how well your models are running over time. So this is a good way of saving your results so you can go back and see how your forecasts track over time. So to create a post list, if you go to the Setup tab, very much like you do the edit the extract, go to Edit a Post. It looks very much like the extract editor, it's just the post editor. And so instead of it being a destination from like an Oracle database or CDA, it's going from Forecast DSS to, for this example, to the Oracle database. You could also go to CDA, but it's going towards the Oracle database in this sense. So this is what it's named in the DSS file that we're looking for, and this is what's going to be named when it's posted to the Oracle database. So there's different ways of doing this. If you have any questions on how to do this, feel free to reach out. The post list just kind of worked in the opposite direction the extract list worked. So let's talk about some SWMS forecast methodologies. There are kind of two main philosophies when we're doing forecasting. There's one, I always like to say it's not a competition, but I'm right and everyone else is wrong. But my philosophy I've always done is create a new forecast each day. Each day is a new day. So I like to do a lot of save back to base, and then I create a new forecast the next day, and it's just a whole new process. This is dependent upon how your office is set up. So I'm doing a fresh extract each day. St. Louis, we look back at a 30-day look back, so we're not so concerned about the initial conditions, so they have less of an influence. It also saves everything I've done for that day, and it's its own isolated thing. It's its own isolated forecast, and I'm not losing the fidelity of what I've done in that model, so that when I create the next one the next day, I have a whole other copy of everything, and so I create a lot of folders for that. So there's one reason for doing a new forecast each day. Continuous forecasting is the process where you would open the previous day's forecast, and you're just extracting the last 24 hours or last however many hours it's been since you ran that forecast last. The reason that this would be advantageous is you don't have to change the initial conditions. They have been calibrated for when the model started. So those initial conditions don't change because you're always using that start time continuously. One disadvantage to this, there's disadvantages to everything, is that your time window grows and grows and grows as you go. So at some point you'll have to reset. So a new forecast will have to be created. So I'm sure offices that do continuous forecasting have some process where they say we want to look back 7 days or 14 days to start with, and we want to purge it or stop it when we reach 2 months, whatever that threshold is. So there are advantages and disadvantages to each. The new forecast each day, you kind of have to check those initial conditions every time you create a new forecast. If you do continuous forecasting, you don't have to check them. You kind of calibrate it one time, but you do have to understand you're creating a larger file and there's a longer simulation time as you go through it. So check with your office, figure out what your policies are. If you're the one that's trying to set these, reach out to any one of us on the water management team, and we can give you the pros and cons of what we think would work best for your region. Additionally, some of the advanced features in the CABI that might help out your office is like team forecasting. Team forecasting allows you to save a CABI watershed up to like a shared drive, And so if there's any changes to a model and you save it back to base and you want to sync it with the master watershed that might be up on the shared drive, you can sync an HMS model or a ResSim model, and then the team, the other users of that CAVI, will get those updated pieces of information. This is great for if you have different individuals working on each individual model. So if you say you have a hydrology team that does a hydrology, and you have a reservoir team, and you have a hydraulics team, and you have an economist, and they're all working on different parts of it, team forecasting is a great thing because then you can post up different results to it. They can extract those results down, and they're all working from the same forecast run. Also, it helps with managing a watershed. So even if it is one person that runs the entire model sequence, maybe somebody maintains the scripts or maintains the reports. You can post those up to that master watershed, and then those are available to the users of that watershed. It's also a great place to back up your CAVI watersheds. So you can always post them up there and back up your watersheds or back up your forecast. And so when you do sync to your master watershed, it'll let you know which ones are out of date. So like, for example here, this net view has been updated, so is HMS and so is RAS. And there are some notes in here to let you know, hey, this has been changed, and this is the reason it's been changed, and maybe you consider syncing it with the master watershed. So you can choose not to, or you can choose to sync it. So this is a great way to update and keep sync with everyone else's watershed. So this is a great way to manage if you have multiple people managing the same watershed. So if you have any questions about our software, need some help, or are looking for additional training, check out these links, or they're also available in the description down below. Thank you for your time.